Let's get some practice taking sums of infinite geometric series. So we have one over here, and just to make sure that we're dealing with the geometric series, let's make sure we have a common ratio. So let's see, to go from the first term to the second term, we multiply by 1/3, and then go to the next term, we are going to multiply by 1/3 again, and we're going to keep doing that. So we can rewrite this series as 8 plus 8 times 1/3, 8 times 1/3, plus 8 times 1/3 squared, 8 times 1/3 squared. Each successive term, we multiply by 1/3 again. And so when you look at it this way, you're like, okay, we could write this in sigma notation. This is going to be equal to, so this, the first thing we wrote is equal to this, which is equal to, this is equal to the sum, and we could start at 0 or at 1, depending on how we'd like to do it. We could say from k is equal to 0, and this is an infinite series right here. We're just going to keep on going forever. So to infinity of, well, what's our first term? Our first term is 8, so it's going to be 8 times our common ratio, 1/3, to the k power. And let me just verify that this indeed works. And I always do this just as a reality check, and I encourage you to do the same. So when k equals 0, that should be the first term right over here. You get 8 times 1/3 to the 0 power, which is indeed 8. When k is equal to 1, that's going to be our second term here. That's going to be 8 times 1/3 to the first power. That's what we have here. And so when k is equal to 2, that is this term right over here. So these are all describing the same thing. So now that we've seen that we can write a geometric series in multiple ways, let's find the sum. Well, we've seen before, and we prove it in other videos, if you have a sum from k equals 0 to infinity, and you have your first term a times r to the k power, assuming this converges, so assuming that the absolute value of your common ratio is less than 1, this is what you needs to be true for convergence, this is going to be equal to our first term, which is a, over 1 minus our common ratio. 1 minus our common ratio. And if this looks unfamiliar to you, I encourage you to watch the video where we find the formula, we derive the formula for the sum of an infinite geometric series. But just applying that over here, we are going to get, this is going to be equal to our first term, which is 8. So that is 8 over 1 minus our common ratio, over 1/3. And we know this is going to converge because our common ratio, the magnitude, the absolute value of 1/3 is indeed less than 1. And so this is all going to converge to, 8 over 1 minus 1/3 is 2/3, which is the same thing as 8 times 3/2, which is, let's see, this could become, divide 8 by 2, that becomes 4, and so this will become 12.